Would you trust a weather app after it sent you into the rain?
That sounds like a question from someone with very wet shoes.
Look at them. The app said it would be dry this afternoon. Hello, everyone. I'm Mia, and this is our podcast about everyday science.
And I'm Alex. Today, our science talk begins with a small weather problem.
Small for you. I carried books, cakes, and 2 bags through that rain.
Fair point. What did the app show before you left home?
It showed a sun, 1 cloud, and a number, 30% rain.
So it did not say there was no rain.
Wait, does 30% not mean light rain for 30% of the day?
Not in that app. It means rain is possible in our area.
Then I read the number in the wrong way.
Many people do. The little sun picture can also feel too strong.
I saw the sun and stopped thinking. That was my first mistake.
Maybe, but the app could show the message more clearly too.
Good, I don't want all the blame for my wet shoes.
Science often gives us a chance, not a promise.
But people want a simple answer, rain or no rain.
I understand. A simple answer helps when you must make a quick plan.
We plan to show children the night sky in the garden.
Now the clouds are thick and the grass is wet.
Should we stop the whole activity?
I don't think so. We can move the first part inside.
We have pictures of the moon and a small model of Earth.
Right, we can also watch the sky through the large window.
And if the rain stops, we can go out later.
That's a good plan. We use the report, but we also watch the real sky.
So using science does not mean following one screen without thinking.
Exactly. We check the information and ask what it really means.
Still, I feel a little angry when the answer is not sure.
I see it differently. An honest, unsure answer is better than a false promise.
Maybe, but we need to teach people how to read that answer.
I agree with that. A number alone is not always helpful.
Could the app say, take a small umbrella just in case?
Yes, but the final choice is still yours.
Next time, I'll check the number, the clouds, and the window.
And perhaps take an umbrella when books and cakes are coming too.
Very funny. At least the cakes are safe in the library kitchen.
Then our problem has a useful result. An indoor plan and dry cakes.
This small story shows why science can feel helpful and difficult together.
It gives information, but we must understand the limits of that information.
That makes me think of another time when I trusted a simple answer.
Was that answer on another app?
No, it came from a plant video, and my poor Basil paid the price.
You said a plant video caused trouble. What did it tell you to do?
It said cold coffee helps basil grow, because coffee has useful food for plants.
And you poured coffee into the pot.
Only a little at first. The speaker looked confident, so I believed him.
Did he show a real test, or just one healthy plant?
Now that you ask, he showed 1 plant before and 1 plant after.
Were you sure it was the same plant?
No, I was busy looking at the large green leaves.
What happened to your basil after you tried the tip?
For 2 days, nothing happened. Then some leaves became yellow and soft. I gave it more coffee because I thought the first amount was too small.
Oh, Mia, more is not always better.
I know that now. The pot also started to smell strange.
Did you use coffee with milk or sugar?
No sugar, but there was a little milk in it.
That is important. The video may have used plain coffee.
So I did not really follow the same method.
Right? Did anything else change during those days?
I moved the pot from my window because the afternoon sun felt too hot.
Where did you put it?
On a shelf near the kitchen. It had much less light there.
Then coffee was not the only change. The light changed too.
The room was warmer, and I used a different pot as well.
That makes the result hard to understand.
But the plant got worse after the coffee. Isn't that enough proof?
I don't think so. Something happening later does not always show the cause.
I disagree a little. The smell began right after the second cup.
That is useful information, but we still have several possible causes.
The milk, too much liquid, less light, or the warmer room.
Exactly. A fair test tries to change one main thing at a time.
Could we test the idea again, without hurting many plants?
Yes, we can use 2 small basil plants of about the same size.
Both plants should have the same soil, pots, light, and room temperature.
Good. We also give them the same total amount of liquid.
One gets water, and the other gets plain coffee mixed with water.
We should use only a weak mix and check that it is safe first.
Let's write the amount down, instead of saying a small cup.
Great idea. We can measure 50 milliliters for each plant.
I'll label the pots A and B, then take one photo each morning.
Measure the plant height and count any yellow leaves too.
What if both plants change in the same way?
Then coffee may not be the main reason, or the test may be too short.
And one small test cannot answer everything.
True, but it can help us ask a better next question.
That feels different from trying to prove the video was wrong.
Science is often more useful when we test an idea, not attack a person.
But online, people often argue about the person before checking the idea.
Yes, what happens when a science message comes from someone we already like?
I have an example. This creator says houseplants can clean all the air in a room.
All the air, that is a very strong claim.
She usually explains science well, and her videos make people care.
That is valuable, but a good speaker can still make a mistake.
You sound doubtful before watching the video.
I'm doubtful of the word all. I am not judging her yet.
That's fair. Let's watch the important part together.
She says a study found that plants removed harmful chemicals from air.
So the claim has a real study behind it.
Yes, but we need to know how the study was done.
The video shows a plant inside a clear box.
That box is small and closed. A normal room is much larger and has moving air.
Are you saying the study is useless?
Not at all. It shows what plants can do under those test conditions.
But it may not show what one plant can do in my bedroom.
Exactly. The missing step is moving from the test box to a real home.
I still think the video is helpful because it gets people interested.
I partly disagree. Interest is good, but a false promise can guide bad choices.
What bad choice could come from buying a few plants?
Someone might keep windows closed and ignore smoke, dust, or poor ventilation.
I hadn't thought about that. The message could replace a better action.
Right, plants are pleasant, but they are not a complete air system.
Still, I don't want science talks to become cold lists of warnings.
Neither do stories and clear pictures can make difficult ideas easier.
Then perhaps the problem is not her friendly style.
The problem is the large promise and the missing limits.
How could she improve the message without making it boring?
She could say plants removed some chemicals in small closed test spaces.
Then add that homes have different sizes, airflow, and sources of pollution.
Yes, she could still end with a positive point about keeping plants.
Plants can make a room pleasant and may help people feel calmer.
That is a more balanced message, as long as we describe the evidence honestly.
What should a listener check before sharing a science video?
First, ask what the main claim is. Can you say it in one clear sentence?
Second, check where the information came from.
Yes, a study, a public health group, or only another short video.
Third, look for important details that may be missing.
Such as the number of tests, the conditions, and how large the effect was.
I would also ask if other trusted sources report a similar result.
Good, agreement does not prove everything, but it can make a claim stronger.
What if two experts disagree? That often makes viewers more confused.
Then we should compare their evidence, not just their confidence or job titles.
And we can say, I don't know yet, instead of choosing a team at once.
That answer may feel weak, but it can be the most honest one.
I now see why you reacted to the word all, not to the creator herself.
And I see your point that a warm style can open the door to science.
We do not fully agree, but we found a better version of the message.
Now, can we use this checking method on something simple in this room?
Here is a simple question. Which cup keeps tea warm for longer?
We have one heavy ceramic cup and one thin metal cup.
I think the ceramic cup will win. My tea stays warm in it at home.
I think the result may be close. Shall we test it?
Yes, we need the same kind of tea in both cups.
We also need the same amount of water at the same starting temperature.
I'll measure 200 milliliters for each cup. The water is ready. I'll pour it carefully now.
Good. I will start the timer when both cups are full.
Should we put lids on them?
We do not have two matching lids, so let us leave both cups open.
That keeps the test fair.
Put them on the same wooden board, away from the open window.
Why does the window matter?
Cold moving air may cool the cup nearest to it faster.
Right, we want the cup material to be the main difference.
The timer has started. What do you think will happen first?
The metal cup will feel hot outside, then lose heat fast.
That is a clear idea. Let us write it down before we see the result.
Can I touch both cups?
Carefully, touching tells us how the outside feels, not the tea temperature.
The metal cup feels much hotter. I still think it will cool first.
5 minutes have passed. Let us measure the metal cup.
The number is higher than the starting temperature. That cannot be right.
Wait a second. The thermometer is touching the hot bottom of the cup.
So our first reading is not useful.
It shows a measuring problem, not the true temperature of the tea.
Should we hide that mistake from our listeners?
No, mistakes are part of real tests. We should explain and correct them.
I'll hold the thermometer in the middle and keep it away from the sides.
Stir the tea once, then wait for the number to stop moving.
Now the metal cup is 64 degrees.
Use the same method for the ceramic cup.
The ceramic cup is 66 degrees. It is warmer, but only a little.
Your idea was right in this test.
I won. Ceramic cups are always better.
Not so fast. We tested only 2 cups for 5 minutes.
Right, another ceramic cup may be thinner, wider, or colder at the start.
The shape and size may also change how quickly the tea cools.
Then our result is small, but it is still real.
Yes, we can say what happened here without making a huge promise.
In our test, this ceramic cup kept the tea 2 degrees warmer.
We could repeat the test 3 times and check the result again.
We could also measure after 10, 15, and 20 minutes.
That would give us a clearer picture of how both cups cool.
This test gives us a simple plan for everyday science.
Ask a clear question, change one main thing, and measure with care.
If something looks wrong, check the method before making a strong claim.
And tell people what your test cannot show.
We began with rain, then plants, online videos, and finally 2 cups of tea.
Each example gave us information, but none gave a perfect final answer.
That does not make science weak. It gives us space to learn more.
We can be careful and curious at the same time.
Thank you for joining our positive and slightly wet science talk.
Keep asking good questions, and remember to bring an umbrella.
Goodbye for now. We'll meet again with another everyday question.